In all, 6 questions were given from the topic Ellipse under coordinate geometry in the JEE Main examination, in the January 2024 session. So in the January 2024 session of JEE Main, 6 questions were given from the topic ellipse, and we have already discussed the first 3 questions. Now we will now discuss the next 3 questions. This question has appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given question is, let capital P be a parabola with vertex 2, 3 and directrix 2x plus y is equal to 6. Let an ellipse E given by x square by a square plus y square by b square is equal to 1, where a greater than b, of eccentricity 1 by root 2 pass through the focus of the parabola P. Then the square of the length of the latus rectum of the ellipse E is. We are given 4 options. We are given a parabola denoted by capital P, whose vertex is at 2, 3 and the directrix 2x plus y is equal to 6. And you are given an ellipse E given as x square by a square plus y square by b square is equal to 1, where a greater than b, with eccentricity 1 by root 2. Given this ellipse passes through the focus of the above parabola P, then required to find the square of the length of the latus rectum of this ellipse. We will now discuss the solution of this problem in detail. We have the parabola denoted by P with vertex at A, whose coordinates are 2, 3 and directrix D, whose equation is 2x plus y is equal to 6. The directrix equation, let us denote it by 1. Have a diagram. Let S, the coordinates alpha, beta, be the focus of this parabola P. This is the parabola P, right, with vertex at A, whose coordinates are 2, 3 and its focus is S with coordinates alpha, beta, and the directrix of this parabola is given here. So D, whose equation is 2x plus y is equal to 6. Agreed. Now, what is our goal? Our goal is we have to obtain the coordinates of the focus S, that is alpha, beta. Then this ellipse passes through the focus of the parabola. Then continue. Then we have to find the square of the length of the latus rectum of this ellipse. Agreed. Now, let the point of intersection of the axis AS, what is the axis of this parabola? AS, and the directrix D is Z. We want to find the coordinates of Z, and having obtained the coordinates of Z, we can find out the coordinates of S. Now AZ is perpendicular to the directrix D, right? We want to write the equation of AS. To write the equation of AS, it is passing through A, 2, 3. If I know the slope of AS, then I can write down the equation of AS. So for that, AZ is perpendicular to D. Therefore, the slope of the directrix is M1 is equal to -2, right? And because it is perpendicular, the slope of AS will be, the slope of the AS means slope of the axis will be 1 by 2 because M1, M2 is -1, right? Now, the slope of the axis we know, and it is passing through the vertex A with coordinates 2, 3. We can write down the equation of the axis. So, the equation of the axis AS is y minus 3 is equal to M2 1 by 2 into x minus 2. Simplifying, we get 2y minus x minus 4 is equal to 0. Let's call this as the equation 2. Right. So, equation of the AS, the axis is known. The equation of the directrix is known. So, solve these two equations, you will get the coordinates of Z. So, solving this equation 1 and this equation 2, we get the coordinates of Z as 8 by 5, 14 by 5. Now, solve. Take this equation 1 and the equation 2 and solve. Right, two equations, two unknowns. We are very familiar finding the solutions of two equations and two unknowns. We continue in the next slide. Right, that's the diagram, and we have Z, the coordinates of which are 8 by 5, 14 by 5. Agreed. Now, how to find the coordinates of the focus, alpha, beta. Now, what we recall is that the vertex A is the midpoint of ZS. The vertex A is the midpoint of ZS. So, the coordinates of Z are known, the coordinates of A are known, and alpha, beta can be obtained. So, therefore, the coordinates of A 2, 3 is the midpoint of ZS. ZS means alpha plus 8 by 5 by 2, beta plus 14 by 5 by 2. Now, so this will imply alpha plus 8 by 5 is 4, right? 2 2s are 4. Beta plus 14 by 5 is 2 3s are 6. From this, so alpha will be 4 minus 8 by 5, that is 12 by 5, and beta will be 16 by 5. So that's, we got the coordinates of the focus S. Now it is given the ellipse E given by x square by a square plus y square by b square is equal to 1, where a greater than b passes through the focus S alpha beta of this parabola P. So substitute x is equal to alpha, y is equal to beta in the equation of the ellipse. So that will be 12 by 5 whole square by a square plus beta, that is 16 by 5 whole square by b square is equal to 1. Let's call this as the equation 3. Equation 3. Right. Given the eccentricity of this ellipse is given to be 1 by root 2. 1 by root 2. Then in that case, we have the formula for eccentricity. E square is equal to 1 minus b square by a square. So E is given to be 1 by root 2. E square is 1 by 2 is equal to 1 minus b square by a square. From this, we will get b square by a square is equal to 1 by 2. Right? And a square, if you want, it will be 2b square. Now go to the equation 3. Substitute 2b square for a square in the equation 3. From 3, 12 by 5 whole square by a square 2b square plus 16 by 5 whole square by b square is equal to 1, using this one. Right. From this, we can very easily solve for b square. So b square is equal to, we have solved, and we got 328 by 25. The solution. How to solve we have shown here. Right. B square is known. So now the square of the length of the latus rectum of E. The length of the latus rectum is 2b square by a. The square is its square. That will be equal to 4 into b square by a square multiplied by b square. Right. Because it is 4b to the power of 4 by a square. That is written like this. 4 into b square by a square. We have already computed here. It is 1 by 2. 1 by 2. Into b square we have already seen, 328 by 25. Simplifying, we will get 656 by 25. Let's look at our options. Our answer 656 by 225 appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of this problem. I am sure that you have understood the solution of this one. Let's now move to the next question. This question has appeared in the JEE Main exam held on 1st February 2024 in the first shift. The given question is, let x square by a square plus y square by b square is equal to 1, where a greater than b is an ellipse. We are given an ellipse equation whose eccentricity is 1 by root 2. The eccentricity of this ellipse is 1 by root 2. And the length of the latus rectum, of this ellipse is given to be root 14. Now, then the square of the eccentricity of x square by a square minus y square by b square is equal to 1 is. What is this equation? This is the equation of a hyperbola. So, required to find the square of the eccentricity of this hyperbola. And we are given 4 options. Right. Let's now discuss the solution of this problem in detail. So, that's the given question to us along with the options. We have the given ellipse. E, x square by a square plus y square by b square is equal to 1, where a greater than b. Right. Given the length of the latus rectum of this ellipse is 2b square by a, that is root 14. Given the eccentricity of this ellipse, E with suffix E, is equal to 1 by root 2. That is equal under the square root of 1 minus b square by a square is equal to 1 by root 2. Now squaring on both sides, we get 1 minus b square by a square is equal to 1 by 2. From this we get b square by a square is equal to 1 by 2. Agreed. So we are given this hyperbola h, x square by a square minus y square by b square is equal to 1, where a greater than b is already there. So we now find the eccentricity of this ellipse, of this hyperbola. So we have EH is equal to under the square root of 1 plus b square by a square. You have to remember the formula. That is equal to b square by a square is 1 by 2. That is under the square root of 1 plus 1 by 2. That is under the square root of 3 by 2. So what is that we want? We want the square of the eccentricity of the hyperbola. So EH square is equal to 3 by 2. And let's look at our options. Our answer 3 by 2 appears against option 1. So the answer to this question is option 1, and that is the simple solution of the given equation. Right. But I want to make a remark, a note on this. Let's look at this one. This one, what we are showing, this is a part of the hypothesis. That is, we are given the length of the latus rectum is 2b square by a is under the square root of 14. We have not utilized, you have not used this hypothesis at all to arrive at the given answer. So, please note down that this part of the hypothesis we have not used, but still we got the answer. So, that is not necessary, it means. Okay, that is the discussion about that question. I am sure that you have understood. Let's now move to the next question. This question has appeared in the JEE Main exam held on 1st February 2024 in the second shift. Let capital P be a point on the ellipse x square by 9 plus y square by 4 is equal to 1. So we are given a ellipse and P is a point on this ellipse. Let the line passing through P parallel to y axis meet the circle x square plus y square is equal to 9. So you are given a circle x square plus y square is equal to 9, and you are given that the line passing through P parallel to y axis meet this circle at a point Q such that P and Q are on the same side of x axis. So you are given further P and Q are on the same side of the x axis. Right. Then the eccentricity of the locus of the point R on PQ such that PR is to RQ is equal to 4 is to 3 as P moves on the ellipse. And we are given R is a point on the line joining PQ such that PR is to RQ is equal to 4 is to 3. That means R divides the line PQ in the ratio 4 is to 3 internally. Then find the coordinates of R. Then as P moves, this point R also moves, and required to find the eccentricity of the locus of this point R. Most probably the locus of this R might be an ellipse or else a hyperbola, whatever it is, and the locus of that point P, some conic, you have to find out some conic section, you have to find out the eccentricity of the locus. The question looks, a big one, but the answer is simple. That we will see in the next slide. We have the ellipse E, x square by 9 plus y square by 4 is equal to 1. It's a given ellipse to us. Right. So let us look at the diagram. This is our ellipse E. Agreed. Center is the origin. Right. And given P is a point on E, because P is a point on E is an ellipse like this, and the coordinates of P in the parametric representation can be written as A cos theta, comma B sin theta, where A is 3, B is 2. Right. Therefore, the coordinates of P in the parametric representation will be 3 cos theta, comma 2 sin theta. What is P? P is a point on the ellipse. Right. We are given the circle C, x square plus y square is equal to 9. It is a circle with center at the origin and a radius 3. Right. So the circle is like this. The ellipse is entirely contained in the circle. Right. Right. What is given? Given the line through P parallel to y axis meets the circle C at Q. So this is the line through P parallel to y axis, meet the circle C at Q, and P and Q are on the same side of x axis. So this is are on the same side. Okay. So now the circle's equation is x square plus y square is equal to 9, and the coordinates of Q in the parametric representation will be a cos theta, that is, and a cos theta comma a sin theta. A is 3 cos theta, 3 sin theta. Agreed. We are also given R is a point on PQ, the line joining PQ, such that PR is to RQ is 4:3. That means R divides PQ internally in the ratio 4:3. And let us take the coordinates of R be h comma k. So PR is here, R is here. So the coordinates of P are known, the coordinates of Q are known, and ratio 4:3 is known. So the coordinates of h comma k are 4 times 3 cos theta plus 3 times 3 cos theta by 4 plus 3, comma 4 times 3 sin theta plus 3 times 2 sin theta by 4 plus 3. When simplified, it will be 3 cos theta, comma 18 by 7 sin theta. Agreed. So therefore, h comma k is 3 cos theta, comma 18 by 7 sin theta. Now what the P is doing? P moves on the ellipse. P moves on the ellipse. As P moves on the ellipse, theta varies from 0 to 2 pi. As theta varies to 0 to 2 pi, the locus of hk will be an ellipse. How that will be? H by 3 whole square plus k by 18 by 7 whole square is equal to 1. So the locus of this point R h comma k as P moves on the ellipse is x square by 3 square plus y square by 18 by 7 square is equal to 1, and obviously it is an ellipse. Here x square by a square is 3 square plus y square by b square is 18 by 7 square is equal to 1. Now required to find its eccentricity. Right. Now E is equal to under the square root of 1 minus b square by a square. That is equal to under the square root of 1 minus b square 18 by 7 whole square into 1 by a square, that is 1 by a square is 1 by 3 square. Simplify. We will get under the square root of 1 minus 36 by 49. Further simplification will give you under the square root of 13 by 7. That is the eccentricity. Now you are asked to find the eccentricity of the ellipse, right? So the answer root 13 by 7 appears against option 1. The answer to this question is option 1. And that is the detailed discussion of this solution. And I am sure that you have understood this solution. And in this we have discussed the questions 4, 5, 6 from the section ellipse that have appeared in the JEE Main January 2024 session. I am sure that you have understood the solutions of all these problems, and I wish you all the best. Thank you.